There's the beat, and we will start. A radical, and again, I remind you, radical is the word I'm always going to use because it's the real word and it covers everything, not just square roots, which is what you're used to seeing when you see that sign. A radical is any expression with that sign. Now that sign can have more to it than that, can't it? Right? That is a square root. Remember that it's really this, y, root x. Y is the what? I named it yesterday. Who remembers? Index. And x is the radicand. Radicand is not really an important word. That's a math word. I won't use it very often. But index, I will use all the time. Be aware of what the index is. And we remember what the index is. What does it mean? That's the number of factors that we are seeking. Understand? So a square root would have a little 2 there. Would we ever write the 2? No, it's blank. Then I'm looking for 2 factors. Square root of 16, 4 times 4. I'm looking for a group of 2. Everybody good? All right. An entire radical. I'm highlighting the word entire. An entire radical looks like this. It's got a radicand, but it has no coefficient. What's a coefficient? Who remembers from previous math classes? Nobody knows what a coefficient is. I see. Okay. I'll write a mixed radical over here, and I'll see if you can tell me the difference. A mixed radical looks like this. Z, Y, X. What's the difference? There is a coefficient here. So what is the coefficient? The number out in front. Okay? So a quick reminder for those of you that don't remember, that's a variable. That's a coefficient. What math does a coefficient perform on the variable? Multiplication. Coefficient is multiplying. Now, I'd like to remind you guys of something. It doesn't have to be with a variable. For example, 2 pi. Is the 2 a coefficient? Yes, it's multiplying pi by 2. Everybody good? 2 cos 7. The 2 is still a coefficient. It doesn't have to be a variable, okay? Coefficient comes in front of an expression and multiplies whatever it's attached to. Everyone remembers this now? Okay. So I want for you guys to convert to a lowest terms mixed radical. That's what we are doing today. The square root of 72. All right? Now, let's look at the square root of 72. First of all, does it have a square root? You wrote the list out yesterday with 72 on it. No, it is not. So 72 has no square root. If you push square root of 72 on your calculator, what do you get? An irrational number. Is that irrational number exact? No. How long will that irrational number go? Forever and ever and ever. Like on iCarly, that weird chick that kidnaps them. Thanks, Sammy. One person. Everybody wants to hit square root 72 on their calculator and thinks that that is the square root of 72. It is not. Up until this year, that has been the square root of 72, hasn't it? When you were in grade 8, you were doing Pythagoras questions, you square rooted at the end, and whatever you got, you rounded it off to a couple of decimal places, right? And that was good enough, wasn't it? That is not good enough now. Okay? Now we look for exactitude. And we've had this example in this course, right? When we were doing the surface area of a cylinder, you guys all wanted to have a decimal, right? And how did I want you to leave it? Like 60, dumbass. I wanted you to leave it like 66 pi, right? That's what we are going for now. We are avoiding decimals. We want exact answers. So I look at this expression and I say to myself, self, this means, what is my index here when we don't write it? 2. What does that 2 mean? That I need groups of how many factors? Groups of 2. All right? So this guy, what we have to do is he must be factored. All right? Now I'm going to show you guys 3 ways to do this. All of you over on the left here, factor this however you like to factor. Okay? We've already done 72 today. I did it on the top. It was the warm-up thing, right? I did it in red up here. It's erased now. But all of you factor 72. 72, 8, 9, 2, 4, 2, 2, 3, 3. And the root of 72 is also the root of 2 times 2 times 2 times 3 times 3. Correct? It is also the root of 2 cubed times 3 squared. Still okay? All right. Is everybody good with that? Everyone can get to there? No problem, right? Now, what is my index? It's 2, which means I'm looking for groups of 2, yes? Is there a group of 2 2s? There's 3 of them. So can I get 2 of them out? Yes. So these 2 are coming out front. Now you guys are smart kids. What's the square root of 16? 4. Why? Because 16 is 4 times 4, correct? So I bring out the 2 4s, but I'm only bringing them out as 1 because I'm looking for the set. Agreed? So I'm bringing out a set of 2. So how many 2s do I write out in front? When it was the square root of 16, 4 times 4, I brought out 2, but I wrote 1. So what am I bringing out here? I'll make it easier. What's the square root of 4? 2, because the square root of 4 is the same as 2 times 2, correct? I'm looking for a group of 2 factors, so I bring it out, and the square root of 4 is 2. I bring out 2, but I only write 1, because I'm looking for the group. Is everybody with me? Yeah? Okay. So what do I write out in front here when I have a group of 2? I bring out a 2. So now I've got a 2 out in front, and what did I leave under there? There's a 2, and there's 3 times 3, or 3 squared, yes? Is there another group of 2 under there? Is there a group of 2 under there? What? The 3s. So what comes out? A 3. What was left under there? 2. Now I have 2 numbers in front of another expression. Those 2 numbers must be what? Coefficients. What do coefficients do? Multiply. So what do I do here? What's 3 times 2? 6. That is the answer that we seek. That is the exact answer. Because there is no irrational numbers there, is there? Does everybody understand? We're going to do 1,000,000 of these. Don't worry. And I'm also going to show you another way to do it. Is everybody cool? All right. Everyone is good? Don't worry, Sammy, we're going to practice it a million times. Okay? I'm going to show you guys two other ways to factor here. Okay? First one is the way I learned how to do this. We didn't do factor trees. We went like this. 72. Now I look at 72 and I say to myself, I know I need prime numbers, right? 72 is even, so I'm going to divide 72 by 2. 72 divided by 2 is 36. That's even. 2 goes into 36 18 times. 2 goes into 18 9 times. 3, 3. And then you will notice I've got all my prime factors right out here. Everybody see that? You don't have to do it that way. It's just another way to do it. I'd like to give you guys as many mathematical tools as you can. You choose what works for you. So you've got factor trees or this. Everybody good? There's a third way to do it, which I'm going to write in green. Square root of 72. Correct? I'm looking for square roots, right? Well, what happens if I do 2 times 36? Is that 72? So these are the same, aren't they? Does 36 have a square root? What is it? 6. So I can stop right there. Because I know this square root of 36 is coming out here, don't I? So I can go 6, and I left a 2 under there. If you have your square roots memorized, simplifying radicals is that easy. If you don't have your square roots memorized, you got to factor and look for groups. Is everybody good? Yeah? Everyone's cool? Feeling good? Feeling strong? All right, well, let's see. Simplified 99. What must I do? I got to factor it. Who chooses how I factor this? Me. So there's 30 of you in the room. All of you got to factor that. You have choices. Use them. I personally like this, what I call the stair method. That's what I do because it gives me all of my prime numbers in a nice little line. That's what I use. Most of you are more comfortable with factor trees. Go ahead and use them. I don't care. It's up to you. So go. I look at that and I see a group of 2. 3 root 11. Everybody good? Some of you will have done a factor tree. 99. 3, 33, 3, 11. There's your group of 2. Some of you may have done this. Isn't 99 9 times 11? And doesn't 9 have a square root? What is 9 square root? 3. There's my 3, and I left an 11 under there. Is everybody good with at least one of the methods? Yes? All right. So what's 75 going to be? Isn't 75 3 times 25? Okay. What's the square root of 25? 5. So what's coming out of there? 5. What stayed under there? 3. That's the shortcut, easy, quickest way to do it. But some of you probably wanted to go 75, 3, 25, 5, 5. There's your group of 2. Is this factor tree method wrong in any way? No. If you like it, use it. Everybody good? No, of course not, because then 15 you're going to break down to 3 and 5, aren't you? And then your pair is going to be the 2 5s. Right? Everybody good? I'm doing this because that's the easiest way to do it in your head. Find a perfect square. Now, can you mix the two? Is it possible to mix them? What do I mean by that? I'll show you with 80. 80's got to be factored, yeah? Everyone agree? Okay, so what would you break 80 into? You would go 8 and 10. Makes sense. Both of them break down again, don't they? 4 and 2. Why am I going to stop at 4? Because I know 4 has a square root, and it's 2, isn't it, Sammy? So I can stop there. I don't have to go all the way to primes, do I? What about 10? 2 and 5. Isn't there another group of 2? So I know that it's the square root of 4 times 2 times 2 times 5. There's a square root. What is it? What's the square root of 4? 2. There's a group of 2, so out comes a group of 2. And what did I leave under there? 5. 2 times 2 is 4. 4 root 5. Is everybody okay? Previous to today, we finished our factor trees until we had all prime numbers, yes? But now, we don't necessarily need to, because I'm looking for a square, right? So the shortcut here is if you can think of any perfect square that's a factor of your radicand, you can significantly cut your work down, can't you? Right? So if you can break your radicand into factors with squares, you're in good shape, aren't you? So is there a factor of 300 that is a perfect square? 100, right? Isn't this the square root of 3 times 100? Does 100 have a square root? What is it? So what's coming out here? 10. What did we leave under there? 3. Does everybody see how that works? If you can't do that shortcut, then you're doing this. 300, 3 times 100, 10 times 10, 2 times 5, 2 times 5. Agreed? So it's 2 squared times 5 squared times 3, all under there, yes? There's a group of 2, so what comes out? 2. There's a group of 2, so what comes out? 5. And what was left under there? 3. What do I do with coefficients? 5 times 2, 10 root 3. Does this way work? Are you entitled to use it whenever you want? Yes. Is this way tidier? Is it more elegant? Sure. Do you have to do it? No, because this requires you to have your square roots or cube roots or whatever memorized. Understand? The more practice you do with this, the more often you'll find yourself doing this shortcut. Right? But you can always use a factor tree, no matter what. Cool? So let's look at E. E is a nice, easy one to use the shortcut on. Why? Why is E so easy to use the shortcut on? Because this is the square root of 9 times 7, isn't it? Does 9 have a square root? What is it? 3. So out comes the square root of 9, which is 3. What stayed under there? 3 root 7. Everybody cool? Mr. Myers, I don't want to memorize the square roots. Don't. Do a factor tree every time. Because if you factor tree this, 9, 7, 3, 3. Oh, there's my group of 2. right? Who chooses how you're going to answer every question that you have to answer? You do. Okay? Does 32 have a square root that's in its factors? 16. 16 times 2. What's the square root of 16? 4. So what do we leave under there? 2. Everybody good? Do you have to do it that way? Of course not. Could you do this? 32, 2 times 16, 2 times 8, 2 times 4, 2 times 2. 1, 2, 3, 4, 5, right? So isn't this also the square root of 2 to the 5th? How many groups of 2 can I get out of there? 2. So I get a 2, I get a 2, and I left a 2 under there. 2 times 2 is 4 root 2. Same thing. Do I care how you do this? No. As the numbers get bigger, it becomes even easier to do the shortcut. For example, right here. Does 363 have a square root somewhere in it? 121. Because this is the square root of 3 times 121. What's the square root of 121? 11. And what did I leave under there? 3. What if you don't see that? Then you factor tree. Does everybody understand? Again, I say it for the bazillionth time. Who decides? You do. Is everybody cool with the method? Now, if you're not lying to me and you're cool with the method, do you now know how to find every root of every number? Right. Because what's the only thing that would change? There's 3 things involved here, right? The index is the only thing that will change. And the index tells me what, Sammy? How many factors we're looking for. Right now I'm looking for 2. Yes? Turn your page over. Your next number should be these. Yes? These are what you guys have, right? Okay. Now, what does that say? An entire radical. What does that mean? We just defined what an entire radical was on the previous page. What does it mean? No coefficients. Do I have a coefficient here? So I got to get rid of it, right? If there is 1 2 out here, how many 2's had to be under the radical sign? 2. If there's 1 out there, there's 2 under there. So if we're going back, it must be the root of 5 times 2 times 2, correct? Because there would be a group of 2 that came out, right? What is 5 times 2 times 2? 20. Everybody cool? That's what's actually happening. I'm going to give you guys a little shortcut here, though. Yeah, right now we're going backwards to make sure everybody gets it. Then we're going to go on to something else. I forgot about this part when we were talking. 2 root 5. What is not written here that should be? A little 2. That little 2 is an index, but it also looks like something else, doesn't it? What does this part of it look like? An exponent, doesn't it? 2 squared and 5. 2 squared is 4 times 5, which is root 20. Everybody see that? That's a little shortcut, but this is what's actually happening. Everybody cool? So let's look at the next one. What is this really? If there's 1 7 out here, how many are under there? There must be 7 times 7. So this is 29 times 49. 7 times 7, yeah? Can't do that in your head. You're going to get out your calculator. What's it going to be? Pardon me? 1,421. Good. Everybody cool? So what's this one? 4 times what? Four times 6 squared, which is 4 times 36, which is what? 144. Good? Now, this one is extraordinarily tricky. It's crazy tricky. It requires you to remember 9th grade exponents. You're on the right track. Antonio, what do you think that one is? Square root of 300. Okay. So, what would that be? Okay. Okay. So, how does that take into account that sign? What do I need out in front of this? Because you know that the square root of 100, is plus or minus 10, don't you? But in grade 10, we're only looking for the positive, the principal square root, right? So looking at this, what had to come out from under the radical sign? A negative, a 5, or both? I'll remind you of this. What is 2 squared? 4. What is negative 2 squared? Why? Because the negative is included. What is negative 2 squared? That's negative 4. Why? There's no brackets. The negative is not part of the base, is it? You guys already should have, without me telling you, you should have recognized that radicals must be related to exponents, mustn't they? So this negative here, was that ever under the radical sign? Stays right there. Because what does the negative sign really mean? What does negative x really mean? Yeah, whatever x is, it's negative. Okay? But once I put brackets around it, it's not whatever x is, it's negative. It's negative. Everyone understand that very subtle difference? This should have been pounded into your brains in grade 9. If you were in my class, it was. Everybody understand why that works? Yeah? What is this technically? That. Because this negative never lived under here. Got it? Cool? Okay. Everyone is good? Everyone can work both ways with squares? Because a square is the easiest one, right? How many factors are we looking for? Groups of 2. Everyone can work both ways with squares, right? Okay, let's move along. What is different in A? It's cubed. What does that little 3 tell me? I need a group of 3 factors, yes. What, pardon? Okay. Sure. Everyone's cool, right? So now we're looking for groups of 3, which means if I'm going to use that shortcut method, I'm not looking for perfect squares. What am I looking for? Perfect cubes. Now, if you don't have your cubes memorized, can you still do the factor tree? Why? because factor tree always works, right? So this one, I'm going to factor tree it first. What would you guys break 54 into? 6 and 9, 2 and 3, 3 and 3. Do you see a group of 3? Where is it? The 3s. So how many 3s come out? 1. So it's 3, cube root, and what did I leave under there? 2. Everybody good? Now, what if I have my cubes memorized? Then I know that root of 54 is the same as the root of 2 times 27, don't I? Does 27 have a cube root? What is it? 3. And what did I leave under there? A 2. Gouda? Everybody cool? All right. 144. If you know your cubes, you can use the shortcut. If you don't know your cubes, you got to factor tree it. What are you going to do? And then do it. Make your decision. Do it. I'll wait a moment. I did something very different there, didn't I? I used my step method, but I also stopped somewhere. Why did I stop at 8? What is special about the number 8? I've got 2, 9, and 8. What's special about 8? It's got a cubed root. What is it? 2. So I can stop there because I'm looking for a cube root, aren't I? So take out the cube root of 8, which is what? 2, cube root. And what did I leave under there? 9 times 2, which is what? 9 times 2. Got all day. 9 times 2. 18. Everybody good? Now, what if you don't want to stop there? You still don't quite have that grasped, right? You don't have that. So you went and did a full factor tree, right? 144, what'd you divide it by? 12 and 12? Good. Then what'd you divide 12 into? 6 and 2, and then you stop there because you got a 2, right? 6 and 2, and you stop there because you got a 2, right? Then what? 3 and 2. Stop there, stop there. 3 and 2, right? And then you saw 1, 2, 3, 4 2s. 2 to the 4th. And 1, 2, 3s. Yes? And I need a group of 3, right? Well, how many 2s do I have there? 4. I need how many to come out? 3. So I'm going to bring out a 2, and what did that leave under there? One of those 2s. Did my 3s get up to a group of 3? Nope. So it's 3 squared. 2 times 3 squared. 3 squared is 9. 2 times 9 is 18. 2 cube root 18. Does everyone see it? Yeah. Because you want it as simple as possible, right? What's better, 18 or 2 times 3 squared? Which one do you have to think more about to know what the value is? Right. Math is always about getting things to look as simple as possible. Got it? So what about this one? What's different about C? It's 4. So I'm looking for a group of how big? 4. Do I change any other part of my method? No, I don't. I don't change anything else. So I know, because I've done a lot more math than you guys, I know the first couple of fourth roots as well. Okay? 1 is 1. 2 is 16. 3 is 81. 4 is 256. I don't go much past that. Okay? So I think of those and I say to myself, well, 128, 16 might go into 128. So I think to myself, yeah, it does. It goes into it how many times? 8 times. And I know that 16 has a fourth root. What is it? It's 2. So it's 2, fourth root, 8. Are you guys able to do that? Some of you maybe. Most of you probably not, correct? So what did you do? Sammy broke it down to 4 and 32. Then she kept going. 2 and 2, right? 4 and 8, 2 and 2, 2 and 4, 2 and 2. And got 1, 2, 3, 4, 5, 6, 7, didn't you? So I need the fourth root of 2 to the 7th, right? How many? I can get out one group. 2, fourth root, and what did I leave in there? 2 times 2 times 2, 2 cubed, which is 2 times 8. And you get the same answer I did. I just got it quicker because I've done this more than you guys. Am I any smarter? No, I've just practiced more. Okay? Factor tree always works. As you do more of these, you're going to start seeing some numbers that come up again and again. You may have noticed how often 2 comes up, right? I told you that memorizing squares and cubes is a good idea. Memorizing your powers of 2 isn't a bad idea either. But do you need to know them? Of course not. So what about the fourth root of 162? Most of you are going to factor tree, right? 162, and you're going to hopefully you will see that that's 2 times 81, yes? And then, maybe you know 81 has a fourth root, but maybe you don't. But if you go 9 times 9, oh, wait a minute. Yeah, it does. Because what's 9 break down into? 3, 3, and 3, 3. There's my group of 4, correct? So what comes out? 3. What stays under there? 2. Everybody good? It's not hard, right? It's just division. There's nothing fancy about it. If you got through grade 3 and you can divide, you're aces. 108. What are you going to break that down into? 4 times 27, yeah? Can I stop there? I'm going to stop there. Why? Because 27 has a cube root, doesn't it? Because it's on my list. What's the cube root of 27? 3. So what comes out? 3. What stays in? 4. What if you don't recognize 27 is a cube root? Then you keep factor treeing. That's it. That's the only thing you got to do. Everybody cool? What's different about F? It looks the same as E, except what? I only want a group of 2, don't I? Right? So I break it down. What would you break it into? I'll wait for somebody to give me the right answer for that one. So you're going to go 12 and 9. Why are you going to stop there? 9 has a square root, right? What is it? So now I've got 3 root 12. Can I stop there? Yes or no? 12 doesn't have a square root, does it? But isn't 12 4 times 3? Does 4 have a square root? So what comes out? What did 2 and 3 do? Multiply to get 6 root 3. Everybody with me? This is one of the hardest ones to do with a shortcut, right? Because a lot of you wanted to stop here, didn't you? Because you saw the 9, right? I have no problem with you saying that. That's why I put 108 there, because it traps people. Because everybody wants to stop there. You just got to check. Everybody cool? Yeah? Okay, your next page should be turning some of these big ones back to mixed radicals. Is it? Or back to whole radicals. Is it? Yeah. So, it's cubed, so what was under there? 4 times what? 3 cubed, right? Which is 4 times 27, which is 108. Gouda? It's the exact same as the squaring, isn't it? Except I had to put 3 back under instead of 2. Is everybody okay? I'm going to take silence as being yes, you're okay. What needs to go back under here? 5's already there. 6 to what power? 4. So you got to do that on your calculator, because I bet most of you don't know 6 to the 4th power in your head. Somebody tell me the right answer there. I'm working it out right now. Shut up. Really? 36 times 36. Yeah, no, that's right. What about this one? What's going back under there? 7 was already there. 5 cubed, which is what? 875. Is everybody good? Yes? 100%? Okay, here's what I want for you to do. These 4 are the beginning of your work. There's nothing, there's no trickery to it, there's no jiggery pokery, there's nothing. Just simplify those 4. That will prepare you to do this. Okay, so do 6. I don't have the puzzle sheet copied for you. There's a lineup for the photocopier today. Again, did you hear what happened yesterday? Oh, it was this class where somebody, and I still don't know who it was making 60 copies of a 35-page book. I don't know who it was. But somebody tied up the photocopier for like 28 minutes. So I don't have your puzzle sheet again because somebody, and again I don't know who it was filling up the photocopier during first block. Okay, now, Antonio, your hand has been up for a long time. It's going to fall asleep.
I have a question to number 5A because I already did it.
Okay, I'll come back to that in a sec. Okay, so you don't have to worry about the puzzle sheet because I don't have it. Okay, I might give you the puzzle sheet tomorrow just for double extra practice in this. Because like I say, your previous math classes get you to do something and then they stop. I am warning you, simplifying radicals is constant from now on. You need to know how to do it. This is not the end of radicals. Okay? right? It's not like grade 3 where they taught you how to multiply and said, okay, we're done, right? Or we taught you how to add fraction. You didn't do it again for a long time. You need to be real good at this, okay? So you're going to do page 218, but after you have done A, B, C, D, and you guys apparently have an E and an F. What are they? What's E? Root of 384. And what's F? Minus 2 square root 180. Okay. So you guys go ahead and try these. Now, Antonio, you had a question about the first one. The first one is put there to mess with your heads. You can't make a mixed radical, can you? So is that as simple as it gets? So you leave it there. Why is that as simple as it gets? Because it's 3 times 5 times 7, right? Any pairs? No. So you guys have to go. This is what makes math teachers want to take a pen and shove it in our eyes. You guys figured it out. But very often I will get a kid who says, I can't do that one. And I say, why? And the kid says, because there's no pairs. Then you've done it, haven't you? Because what allows you to simplify? Pairs. If there's no pairs there, you can't simplify, right? If I tell you to go put on a clown costume, and there's no clown costumes around, can you put on a clown costume? No. You need pairs to simplify. If there's no pairs, you can't simplify. So what is it? It's done. I'll give you another example. 18 over 25. Can you simplify that? No, so you leave it, right? Don't make the mistake of not knowing when to stop doing work. Do you understand what I'm saying? Everybody understands that, right? When you have the answer, stop. Because it's just as important to know when you're done as it is to know what you're doing. Does everybody understand what I'm saying there? I get a lot of your tests back where halfway through the work, you have the right answer. All you needed to do was stop. But you're not confident enough in your math, and you think there's more to do, and you do a whole bunch more work and end up with the wrong answer. Do you understand what I'm saying? Know when it's time to stop, and stop there. Kiara. Then everything comes out. Did you leave anything under there? I know. 196 is 2 times 7 times 2 times 7, isn't it? Well, take out a 2. Take out a 7. And you didn't leave anything under there, did you? So do you need to write anything there? No, but what do you do with the coefficients that come out? 2 times 7, which is 14. Which makes sense, doesn't it? Because the square root of 196 is 14. It's on your list. Picking up what I'm putting down? Know what you're doing, not how to do it. You understand what I mean? If you only recognize how to do it, then these two questions become very difficult, don't they?
But it's not what is asked.
Change to a mixed... No, I know. But this is technically a mixed radical because that could be the square root of 1, couldn't it? Do we ever write the square root of 1? Do we ever write 1 anywhere? No. Right? And what's the coefficient here? What?
Oh, nothing.
It would be 1, wouldn't it? Right? So, Antonio, you make a very good point. Technically, if I were a real mean person, and you gave me this when I gave you that for an instruction, would I mark that right? I wouldn't technically, would I? If I was a real large bad word for male genitalia, I would mark that wrong. Am I? No. I'm loud, I'm a little obnoxious, I'm funny, I'm smart, I'm stunningly gorgeous, but I am not that. But you will find math teachers that would say that's wrong because I said a mixed radical. So you need to write one there. But I'm not that guy.
I mean, also remember because
well, technically for B, it should be 14 square root of 1, shouldn't it? Because the square root of 1 is 1. 14 times 1 is 14. But I'm not that way. You understand? Why this is written here is to make you realize that you do know how to do it. And your question is perfect because you knew that that doesn't get any simpler. But you were bothered by the instruction, weren't you? Right? We're having this, it's not an argument. You're like, but the instructions say, doesn't matter what the instructions say. You do the math. Right? Everybody cool? I shouldn't have put those two first. I should have put them at the end. But whatever. Yeah. So now you guys finish that off and then you work on whatever the textbook page was, 218. Please notice on your outline this. Okay? You guys are smart kids. Exponents are related to radicals. Radicals are related to exponents. If I gave you everything together, the test at the end of this unit would be big enough to choke a horse. So I do this little middle test on radicals only. Okay? It's bigger than a quiz, but smaller than a test. You understand what I'm saying? Okay? And then at the end of it all, I'll give you an exponent, a test that's heavy on exponents with a couple of radicals to remind you of it. Cool? Okay. So notice that. You guys are smart kids. There's one more lesson. When will we do that lesson? Tomorrow. And we won't do warm-ups or anything because tomorrow's a short day. I'll give you an assignment on it. So this test will be coming early next week. Okay? Now, wait a minute. Monday's no good because it's the first day after a 3-day weekend and you won't have had this marked. Tuesday's no good because it's first block. So it's not going to be early next week. It's going to be Wednesday next week, which is a week from today, is it not? So the 26th. And then I'm going to hand out your cumulative test right now while you're working on your work. And then...
I have a question.
Yo.
In our book it says for lesson number 4, the exercise in the book is page 218, 4 and 5 and 10. So 18.
Okay, so do that.
Okay.
What probably happened is I realized that that was more than you needed to do when I was going through this in the summer. And I changed yours, but I didn't change my old one.
And what does odds mean? Because it's after.
Every other letter. No, every other letter. So A, C, F, or A, C, E. Radical mid-test on Wednesday, what did I say? 26th, right? A week from today. Gouda? All right. Now, guys, if you turn that page over to 79, you see a couple of number line things there. I don't want you to do that. Okay, we're going to go over that tomorrow. Okay? Page 79 in your purple book. It doesn't look like it's new notes because it's technically not, but I don't want you doing anything with that, okay? We're going to do that tomorrow as part of tomorrow's lesson. Everybody good? So you're finishing page 78, and then you're doing page 218 in your textbook. Yes? Okay. I'm going to bring around your cumulative exams right now. today and tomorrow are not good days to go over these. Because we're almost out of time today, right? And tomorrow is a short day.